Okay, Abigail. So, mm, um, lesson 116, this is where it starts to get fun in algebra and it's less tedious. So, we're going to talk about the fundamental counting principle and permutations, probability, and independent events. So, first of all, fundamental counting principle and permutations. Let's say I have three letters, A, B, and C. And I want to know how many different arrangements I can put this in. Well, without repetition, that means without repeating these letters, I can choose any one of those three letters for the first position. Then I'm going to have two letters left. Let's say I pick A. Well, now I've got B and C left. So it means I've got two letters to choose from for the second position. And let's say I pick B. Well, then now I've got only one letter left for the last position. So the way that we would calculate that is through multiplication. Because I could pick any of the three letters to start with, and any of the two remaining left, and then I only have the one that could possibly fit. So we multiply that. 3 times 2 times 1, that would be 6. So 6 different scenarios. So let's illustrate that just to prove the point. So I could have ABC, I could have ACB. Those are the only permutations or different arrangements that I can have where A is in the first one. When I have B in the first one, I could have either A or C or A in that order. And when I have C in the first one, I could have either AB or I could have BA in that order. So 1, 2, 3, 4, 5, 6. I could only have those 6 arrangements when I don't repeat the letters. What if I let myself repeat the letters? Then that means I could have any 3 of those letters in the first seat or the first position, any 3 of those letters in the second position, and any 3 of those letters in the third position. So this is with repetition. Okay, so 3 times 3 times 3 would equal 27. So we can illustrate those. I'm going to pause and write them down because I don't want it'll take forever for me to write them all down. All right, so these are all of the different permutations that you could have if you allow the letters to repeat. And if you see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 in each column, and there's 3 columns. 9 times 3 is 27. So this is every possible solution there with repetition. So this is how you would calculate for every situation that comes along. Without repetition, you're going to decrease each seat by 1 because you're removing one of the options. You can't repeat it. That comes in handy when you're thinking about real life objects. When you're arranging 3 real life things, you can't repeat them. Like if you've got 3 chairs and you've got 5 people, then one person can't sit in a chair in 2 chairs, right? They can't sit here and here. They can only sit in 1 chair. So that's a situation where you might not have repetition. If you're making a sign, however, then it is possible that you could write a letter twice on a sign. So with repetition would be a situation like that. So you're looking for those conditions, and sometimes they're going to tell you no repetition. Sometimes they're going to tell you with repetition. So when they don't tell you specifically with or without, you have to kind of read the situation. Like for instance, our very first problem. It says there are 3 chairs in a row. There are 7 students. So we have 3 chairs. How many different arrangements can these students sit in the chair? 3 chairs. Well, guess what? We can't duplicate a student. We have not gotten to where science cannot clone people. So once the first student, any one of the first students can sit here. So there's 7 students to choose from. So one of those sits here. We remove him from that group of available students, right? So now there's only a possibility of 6 students who can sit in the next chair. When one sits there, we take him away from the group. Now there's only 5 left. So there are 5 possible students that could sit in this last chair. Then we multiply. And that is your solution. It is that easy. It's not hard. It's just you got to think about the scenario. Well, how do we know, how many different arrangements, the situation, and the number that you have available? 7 times 6 times 5 is 210. There are 210 possible solutions or possible arrangements that can be made with 7 students and 3 chairs. Right? Next question. Roger rolls a pair of 2 dice. What is the probability that in 2 rolls he will get a total of 7? So our probability that he will get a 7 and a total greater than 9 and greater than 9. So we have to think about all of the different ways that we can get a 7 with 2 dice. And then we have to think about all of the different ways we can get a number that is greater than 9. So a 7, let's see, I'm thinking first dice, second dice, right? So we could have a 1 and a 6. We could have a 2 and a 5. We could have a 3 and a 4. We could have a 4 and a 3. We could have a 5 and a 2. And we could have a 6 and a 1. So 1, 2, 3, 4, 5, 6. Out of 36, we know that that reduces to 1 out of 6, right? Now, greater than 9. So greater than 9, and we've got first dice, second dice. So let's see, greater than 9, we would have to start with a 6. Let's just start with a big number. 6 and a 3. If we go down 1, we have 5 and a 4. One more, be 4 and a 5. And then 3 and a 6. And there's not another way to get, I'm sorry. Greater than 9. Greater than 9. So all of the numbers greater than 9 would be 10, 11, and 12. So now I have to think about all the ways to get to 11, 12. Sorry, I goofed. I'm going to move this over. I'll leave that like that for now. So 10 would be, let's see. I start with the highest number. Usually that helps me. 6 plus 4. Let's just do these separately. All right, 6 plus 4, 5 plus 5, 4 plus 6. Okay, that's all the ways we can make 10. 6 plus 5, 5 plus 6. And then this is 6 plus 6, and that's the only way. So 1, 2, 3, 4, 5, 6. So 6 out of 36 again. Okay, so this was the first one. This was the second one. 6 out of 36, we know both of these reduce as fractions to 1 over 6. So the answer is going to be 1 times 1 and 6 times 6. 1 over 36 is your probability of rolling a 7 the first time and a number greater than 9 the second time. Okay? That's how we would do that. All right, next problem. There are 5 chairs in a row. There are 9 students. How many ways can these students sit in 5 chairs? 1, 2, 3, 4, 5, 9, 8, 7, 6, 5. We just multiply. 9 times 8 times 7 times 6 times 5. 15,120. That's the answer. That's it. All right, let's look at the next problem. How many 7-digit telephone numbers can be written if the digit 0 cannot appear among the first 3 digits? All right, let's think about a phone number like that. So We can't use 0. We know there's 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. So we cannot use the 0. So that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9 that we can use in the first 3 digits. Because it says we can't put a 0 there. So 9, 9, 9. And it says other digits can be repeated. So that means we can use all 9 in either one of these. Over these remaining 4 digits, there's 10. We can use the 0 here. So there's 10 digits. So we could have all 10 here, all 10 here. So we would say 9 times 9 times 9 times 10 times 10 times 10 times 10. That's a lot of different combinations. 7,290,000. That's how many different combinations can be created with just these numbers. That's a lot. Think about when we add the area code in the front. There's 3 more numbers that can be used, and that's without any limit, and that's with limiting it to not being any zeros here. If we have 10 times 10 times 10 times 10 times 10 times 10, that's a whole bunch, right? It's a whole bunch of numbers. So just within the city, like usually this number right here is just within one city or one zip code, you could have 7 million. 7 million people, and usually you don't have that many. All right, sorry about that. I had to go to the restroom and then the kitchen to get a cookie for breakfast. So we won't tell anybody that. All right, next problem. Let's look and see what we got. Okay, so now we're in lesson. You see how easy that was? It only took 2 problems or 3 problems in order to get through it. So lesson 117 is about letter symbols for sets and set builder notation. Okay, so here's all the ones that you need to understand. This funky looking little N right here, that means natural numbers. Natural numbers are the ones we use to count with. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, ... On and on and on forever, right? Okay, whole numbers. That's going to be the fancy, it has a like symbol, right? Double, it's kind of like a double W, but it's italic. That's whole numbers. And that starts, it's natural numbers if you back up 1. Whole numbers includes the idea of not having anything. Natural numbers does not. There is no 0 in natural numbers, except for like when you get to 10, 20, 30, right? Whole numbers includes the concept of I don't have anything. So it starts at 0. 1, 2, 3, on and on and on and on and on. Okay, then you have what's called integers, which is the letter Z. Kind of fancy like that with a double line through it. This is integers. So this includes the concept of negative values. So it is whole numbers plus negative numbers. So it goes on and on. Think of it as the number line. You have all of these negative numbers, 0, and then all of the positive numbers. On and on in both directions. The integers is the number line, and it's designated with the letter Z. You've also got some other ones that we talk about. You've got reals, which is the double R. That's reals. We know that that just means all numbers everywhere. Then you have the letter Q, which looks like that. and that is rational numbers. That means any number that we can turn into a fraction. You have the letter P, that stands for irrational numbers. An irrational number is any non-repeating, non-terminating decimal. A number we can't turn into a fraction. And then there are complex numbers. Complex numbers are those that require the use of a radical symbol or an imaginary number, like the letter I, right? So these are the ones that you're going to be looking at, the symbols in your domains when you graph. Instead of calling out the domain separately, you're going to start to see these written in the question or written in the graphing directions themselves. Let me show you what I mean. So here it says graph. X is a member of the set of integers, because Z is integers, such that X plus 3 is greater than 5. That's what I mean. Your domain, instead of this being an R to represent all real numbers, and then having the domain written out here separately, now we learn that we can put the domain into the directions for the graph. So what we would do is we would recognize that Z is integers, right? So we start to pay more attention to this right here. Z is integers, if I can spell it right, which that's our domain. So X plus 3 greater than 5, minus 3, minus 3. We're not learning anything new. We're just, we are, but we're just paying attention to the way it's written with our symbols there. So X is going to be greater than 2. So if it's integers and X is greater than 2, then we would put a dot on the 3, the 4, the 5, the 6, the 7, the 8, the 9, the 10, and so forth, right? So because X is greater than 2, and we're only graphing integers. Does that make sense? That's what we're doing. So this one, again, the domain is integers. So X plus 1 greater than 1, subtract 1 from both sides. X is greater than 0 in integers. So every number greater than 0. So that'd be 1, 2, 3, 4, 5, 6, 7, and so on. Not hard. It's just about paying attention to the details. Here we have R. R is reals. So what do we do when we graph reals? We draw the line. So I've got x squared greater than or equal to negative 4 minus 3. Add 4x, add 3 to both sides. All right, so we've got x squared plus 4x plus 3 greater than or equal to 0. When it's greater than, let's go ahead and factor it so it's going to be x plus 3, x plus 1 greater than or equal to 0. We want to identify that because it's greater than, it has to be a positive number. So it's either going to be positive times a positive or a negative times a negative. So we're going to have to test these. So x is either greater than or equal to a negative 3, or x is greater than or equal to a negative 1. All right, so that is up here. X would be greater than or equal to, because of this, greater than or equal to negative 3 or negative 1. Over here, for it to be less than, we just switch the symbol. Less than negative 3, less than negative 1. All right, so they both have to be positive or they both have to be negative to get a number greater than 0. So basically now we just test it. We go back to our original equation. X if x is greater than a -3, a -2, or actually we've got the or equal to, we don't have to think about it. We can just use the equal to. -3 plus 3, -3 plus 1, greater than or equal to 0. So that would be 0, -2. Okay, so this one would be true because 0 times -2 is 0, and that's equal to 0. All right, so now we can assume this one's going to be incorrect because usually it's one of these and one of these, right, when it's greater than. So let's look at one of these. Let's check x is less than or equal to -1. So I'm going to say -1 because it could be equal to -1 plus 3, -1 plus 1, greater than or equal to 0. This would be 2 times 0, greater than or equal to 0. We know this is correct, so this one is going to be the right one. Now, if you want, you can double check these two, but I know that these are not going to be correct because it's one from each pair. So this is what we're going to graph. We're going to graph x is greater than or equal to -3. Actually, it's going to be a conjunction now that I look at it, because x is less than or equal to -1, which is less than or equal to -3. Notice how the open side stays towards the x, the open side stays towards the x. So this is right. So we have a conjunction of -3 less than or equal to x less than or equal to -1. So I take my little pen over here, and it's got the equal sign, so I put the dot, and then I put the dot, and then I draw the line. And it's reals, which is why we graph it with the line. Okay? Easy peasy. And we just keep doing that. We keep doing that for all of these. So let's see. That ends up being the same equation. So x squared plus 4x plus 3 less than 0, x plus 1, x plus 3. So then it's either it's less than, so it's going to be positive, negative, or negative, positive. And when they're mixed like that, they have to be the same pair. So it's going to be this pair or that pair. So we've got x plus 1 would be x is less than -1. I'm sorry. X is positive is greater than -1. This is negative, so x would be less than -3. X would be less than -1. X would be greater than -3. All right, so we'll test those out. We'll test the first one. So that would be greater than -1 is 0 plus 1. 0 plus 3 less than 0. 1 times 3 is not less than 0. So it's going to be this then. This one and this one. That's the cool thing about the less thans. You only have to test one of them to figure out which pair it is. So if x is less than -1 and x is greater than -3, we graph that like this. We would say x is, we circle that and we circle that, and it's reals, so we draw a line through it. If we did not draw a line through it, if it was not reals, we could only graph the -2 as an integer if it was integers, right? So it makes a difference how you graph it. This is the domain now. That's what you're looking for. These are easy. You just gotta knock them out. Takes a little bit of effort. So when you see r squared, That just means there's two number lines. XY is a member of the set of the Cartesian system. That's just another way to say Cartesian system, or a plane, where such that y is greater than x plus 3 and y is less than negative x. All right, so y is greater than x plus 3 and y is less than negative x. So let's analyze this. So I've got y, I'm going to pretend like y is equal x plus 3. Just go replace like that so we can see the equation a little bit better. We know that the slope would be here. It's a 1 over 1, right? It's just invisible. And then a positive 3 is where it's going to cross the y-axis. So I'm going to come in here, and because it does not have an equal sign under it, it's going to be a dotted line. So positive 3, it's a positive 1 over 1. So 1 over 1, 1 over 1, and I'm going to follow that angle all the way down to the other side. And it is a dotted line because there is no equal sign under the inequality. So there's my dots, right, for that one. This one's a dotted line also. So I'm going to do it the same way. So over here, I would say y is equal to a negative 1 over 1 x plus 0, because there is no number here. So that plus 0 is my plus b. That tells me where the line starts. The line starts here. But it's down 1 over 1 because it's a negative slope. So down 1 over 1, down 1 over 1, down 1 over 1. And then I'm going to follow that angle back to this side of the graph. I'm just going to put a dot in between each one just to graph where the line would be if it were included. Now I'm going to look at my inequality symbol. So this one says I want all the points above x plus 3, which is, I know it's this line because the 3 right here. So that means all of this and all of this, right? But I want all of the points below this line, which is crossing the 0. So this line, I want everything below. So the below would be here and below would be here. So that tells me the place where they overlap, I'm going to undo this and undo this. The place where they overlap is this section right here. So that is the section I'm going to fill in. And that's enough for me to know that you picked the right section. Okay, that's how you graph those. Next one. There were 16 nickels, dimes, and quarters whose total value was $1.50. So over here, we have 3 kinds of statements, right? We've done these before. 3 kinds of statements. You've got nickels plus dimes plus quarters, and there's 16 of those. Their value was, so we have 5 times n plus 10 times d plus 25 times q. Their value was $1.50. How many coins of each kind were there if there were 3 times as many dimes as quarters? So the number of dimes is equal to 3 times the quarters. So I can redo this one by subbing in for quarters, or the subbing in for dimes with the quarters. So n plus 3q plus q equals 16. N plus 4q equals 16. N is equal to 16 minus 4q. There's my substitution value for n. So now I have a substitution value for d, and I have a substitution value for n. I'm going to put them both into this problem. So 5, and my substitution value for n is 16 minus 4q, plus 10, and my substitution value for d is 3q, plus 25q equals 150. So 5 times 16 is 80, 5 times negative 4 is a negative 20q, plus 30q, plus 25q equals 150. If I subtract 80 from both sides, I get 30. No, I don't. If I subtract 80 from both sides, I get 70. I don't know where I got 30 from. So that equals 70. And then I would have 35q, because negative 20 and positive 25 is 5. 30 and 5 is 35. Divide both sides by 35, I have 2 quarters. Now I can use this to find the values for both of these. So that would be equal to 3 times 2 would be 6. D is equal to 6. And n is equal to 16 minus 4 times 2 is 8. So n is equal to 8. That's your solution. So 8 nickels, 6 dimes, 2 quarters. Another way that you can check your work is to just multiply and make sure you get $1.50, right? So 10 dimes would be 60 cents. 8 nickels would be 40 cents. And 2 quarters would be 50 cents. That's $1.50. And that's correct. All right. Kevin rebelled at paying $4,320 because this was a markup of 80% of the selling price. So we have selling price is equal to the purchase price plus the markup. The markup was 80% of the selling price. So the markup here is equal to 0.8 times S, which is the selling price. What was the markup and what did the store pay for the item? So we can substitute in this for the M. S is equal to P plus 0.8 times S. So if I subtract 0.8 S, oh, all right. Sorry. I always forget little details. I've got to put the selling price in. $43.20. That's the selling price. I was doing it right the first way. S is equal to P plus 0.8 of the selling price. That was the right thing to do. So if I subtract 0.8 of the selling price from both sides, and this is 1, then that gives me 0.2 of the selling price is equal to the purchase price. So now I can put 0.2. The selling price was $43.20. That equals the purchase price. So now I can do the calculation. 0.2 times $43.20. $864 is the purchase price. And the markup is equal to 0.8 times $43.20. So 0.8 times $43.20 is, the markup is $34.56. So the markup was 3,456 and store cost was $864. All right. The pH of a solution is given by the equation pH is equal to the negative log of H plus, where H plus is a concentration of hydrogen ions in moles per liter. Find H plus in moles per liter, where the pH of the liquid is. All right, so we've done these before, or I know I've done these before, and I don't like them because this is a logarithm, but what you're going to do is you're going to say 5.34 is equal to the negative log of H plus. So this is the pH. So we're finding H plus. So this is going to be a base 10 here. I'm trying to remember how to solve for that. It doesn't matter. I'm going to just look at the answer. Okay. So 0.994. I don't know where that came from. That is not the correct answer. Oh, that's the one for here. Sorry. This is the first answer. So this one is 4.57 times 10 to the negative 6. And the second one, which is 0.00263, that's going to be 0.994. All right, so let's go back to that. Let's see how we got there. I'm going to use my other calculator because it's better. Those are the answers. So we have all right, I can't figure it out. Just playing around on my calculator, pressing buttons. Just write it down. We'll go to the next one. Find C. Again, look, these right here, you can always go to Google, calculator. See if I can get it. Just go to Google and type it in. 5.34 equals negative log H plus. Oh, I've got to put it in the right spot, the whole word. So that would be 4.57 times 10 to the negative 6. So it will give you the alternative form. The scientific notation is the one that we typically want. These are all the steps that are happening. I wish it would show me the so you convert it to negative log 10h equals 5.34. So what you do, all right, I see how you do it now. So you're going to take this number and this sign right here, and this is going to turn into, I'm going to erase, actually I'm not going to erase, I'm going to move all of this down here. So you're taking this and you're going to make this the base 10. So this H plus is going to be equal to 10 to the negative 5.34. And that's what you put in your calculator. I knew there was a way, right, to do it, that there was some methodology there. All right, so then when you rearrange that, then you're going to do 10, and then this gives me the power of 5.34 negative underflow. I don't even know what that means. 10, I'm going to do 10x actually. Let's do 5.34 negative 10x. Okay, so there's the answer. There's how you get there. You do the 10 to that power, and I've got the 10x button on my calculator, so I typed in negative 5.34, and I hit the 10x button, and it gave me this. And then you just count backwards. 1, 2, 3, 4, 5, 6. So that's 4.57 to the negative 6, which is the answer we have right there. 4.57 to the negative 6 times 10 to the negative 6. So there's that one. Oops, I don't know why I did that. I was trying to grab that. So that's how we got that answer right there. So this is going to be the same thing without me having to do the calculations. I'm going to say h plus is equal to 10, because this is a negative sign here, to the negative 0.00263. So I pull up my calculator and I all clear it, and I say 0.00263 negative base 10 equals, and then that gives me 0.994, because I rounded this up to where it dropped. Remember what we talked about, the natural fall of a decimal value? Wherever that has that natural fall, that's where you round it and stop. So this would be 0.994, which is the number, which is our solution right here. That's what h plus is equal to. All right, does that make sense? I don't know why it works that way. I just know there's like a rearranging that happens. It's showing the step by step. The thing that you need to know, this is all of the logic behind it, that when you see it like this, negative log 10, whatever this value is, you're taking this and making it a base 10 and using the sign. When it says is the log 10, change the sign and make that the exponent on a base of 10, just like we have in step 5. That's what you want to do. Okay? All right. And that's what you put in the calculator. This is the thing you put in the calculator, and it gives you the right answer. Let's go back to Jupiter. These I know how to do. For sure, for sure. Okay, so we've got 2 different triangles here. We got the little one. It's a right triangle. This is 6. This is A. This is B. You've got the bigger one. This is 9, because 6 plus 3 is 9. This is 7. And this is A plus C. So we can write our proportions. And I like to color code or orient it the same way, you know. So I've got 6 over 9 is the hypotenuse. The height is going to be B over 7. And then the bases are going to be A over A plus C. Now I can solve for B. 6 over 9 is equal to B over 7. So that's going to be 42 is equal to 9B. So 42 over 9 is equal to B. I can reduce this by dividing both of these by 3. 42 divided by 3 is 14. This is going to be 14 over 3. (42 divided by 3 is 14. 3 down 14 is 42, okay? And then 9 divided by 3 is 3. So 14 over 3 is the value of B. So now that I have that, I can solve for A using Pythagoras' theorem, because A squared plus B squared is equal to C squared, which is 6. So A squared plus 14 over 3 squared is equal to 36. So A squared is, it never grabs when I want it to. A squared plus whatever 14 times 14 is. 14 times 14 is 196. So 196 over 9 is equal to, and I'm going to put this over 9. 36 times 9, that's going to be 324. over 9. A squared, I'm going to subtract this fraction from both sides, minus 196, is 128 over 9. So that's going to be, A is going to be equal to the square root of 128 over 3. Let me find the square root of 128. So if I divide that by 2, okay, so 2 times 64, that's going to be 8. So 8, A is equal to 8 times the square root of 2 over 3. Okay, so now that I know what A is, and I know what B is, actually now that I know what A is, I can use 6 over 9 is equal to, and I can use A, here's my A, 8 times the square root of 2 over 3 over 8 times the square root of 2 over 3 plus C, because we're trying to find C. So now I have a equation that only has the variable C in it, so that's going to let me solve for C. It does look complicated. Don't let that stress you out. We're just going to cross multiply like we always do. 6 times 8 times the square root of 2 over 3 plus C is equal to 9 times 8, that's 72 times the square root of 2 over 3. All right, 6 times 8, that's going to be 48 times the square root of 2 over 3 plus 6C is equal to 72 times the square root of 2 over 3. If I subtract this from both sides, I get 6C is equal to 72 minus 48. 72 minus 48 equals 24. So 24 times the square root of 2 over 3. I can reduce this because 24 is divisible by 3. 6C is equal to 8 times the square root of 2. Now I'm going to divide both sides by 6. 8 and 6 are both divisible by 2. 4 times the square root of 2 over 3 is the value of C, and that is correct. All right, and you would enter it just exactly like that. Fraction 4 square root of 2, 3. Correct. All right. Number 16, we're almost there. 2.0425 repeating. Turn that into a fraction. So this is the value of the number. We're going to multiply that number by 100 because there's 2 places here, so we want to use 2 zeros in this number, so it would shift correctly. So 204.2525 repeating. Okay. Multiply it times a -1. That gives us a negative 2.04 with a 25 repeating. So all of those repeating are canceled. We have 204.25 minus 2.04. 202.21. 100 minus 1 is 99 times n. Divide both sides by 99. We have 202.21 over 99. It's too much for our little brains to handle when we have a decimal in a fraction. So we're going to multiply by the number of places that we have is the number of zeros that we multiply by. So n is equal to 20221 over 9900, which is, I don't think we use a comma for that, but we do use a comma here. That would be your solution. I'm pretty sure that that's the way the commas are used. 20, comma 221 over 9900. Yes, that's correct. All right, 17. This one and one more. So first we got to get to a, come on, 5 over 8x minus 2 over 3y equals 4. We need a common denominator, 24. So I'm going to multiply this by 3 over 3. I'm going to multiply this by 8 over 8. And I'm going to multiply this by 24 over 24. So 15 over 24x minus 16 over 24y equals 96 over 24. We know we can multiply everything by 24, get rid of the denominator. So 15x minus 16y equals 96. There's one of our equations. Other equation, negative 0.15x plus 0.2y equals negative 0.6 times, there's maximum of 2 decimal places, so 2 zeros. So that gives us negative 15x plus 20y equals negative 60. Opposite values. So when I calculate that, I get negative 15x plus 20y equals negative 60. Positive 15x minus 16y equals 96. These cancel. 4y is equal to 36. Y is equal to 9. So there's my y value. Now I just have to find my x value. I'm going to just use this one because there's space underneath it. No other reason than that. 15x minus 16 times 9 is equal to 96. 16 times 9, 144. 15x minus 144. Add 144 to both sides. 15x is equal to 240. Divide both sides by 15. X is equal to 16. So my answer is 16 and 9. This is the answer to this solution here. Okay. Last problem. Solve by factoring. And this is an equation, so it's easier. So we've got 2x squared minus 11x minus 6 equals 0. I subtracted 6 from both sides, and then I just flipped it so that I would have it on the side I'm used to having it written on. That's it. Okay, so 2 times negative 6, it's a negative 12. And I need to find a way for that to equal negative 11 when I combine the factors. So to get a negative 12, I think I'm going to have to say negative 12 times a positive 1. When I add them together, that gives me the right answer. So that gives me 2x squared minus 12x plus 1x minus 6 equals 0. I can factor out a 2x from both of these. So x minus 6. And then this is just going to be x minus 6. So plus 1, x minus 6. So 2x plus 1 times x minus 6. 2x plus 1 equals to 0. Subtract 1 from both sides, and then divide both sides by 2. X is equal to negative 1 over 2. And then if I add 6 to both sides here, x is equal to positive 6. So x is equal to negative 1 over 2 and 6. So I would say x is equal to negative 1 over 2 and 6. And that's correct. All right, and that was the last one. I know these are tricky because you have to type them in the right order and the right thing. This is one of the first ones I did for this lesson. So I really need to go back and change it to where it says X is equal and then has 2 blanks. I may do that for those coming up next year. But that is all we have for this lesson. I will see you in the next one.